Hello everyone, this is Bhumika and today we are going to solve numerical data analysis internal second paper. So let's begin. So first question, we have to write algorithm of Newton forward difference interpolation formula. So let's begin. So step 1, start. Step 2, read n number of arguments. Step 3, for I equals to 0 to n minus 1, read xi and y1 0. Step 4, construct the forward difference table for j equals to 1 to n minus 1, for I equals to 0 to n minus 1 minus j, yij equals to y I plus 1 j minus 1 minus yij minus 1 and I and j. So we have to form a loop, for loop लगाएंगे, देन उसको रीड करेंगे और फिर रन कंस्ट्रक्ट करेंगे हमें फॉरवर्ड डिफरेंस टेबल। स्टेप 5, हम फॉरवर्ड डिफरेंस टेबल को प्रिंट करेंगे फॉर आई इक्वल टू 0 टू n माइनस 1, फॉर j इक्वल टू 0 टू n माइनस 1 माइनस j। अब प्रिंट कर देंगे एंड j, नेक्स्ट लाइन एंड आई। स्टेप 6, रीड ए पॉइंट ऑफ इंटरपोलेशन। Step 7, we have to assign h. H is basically step size x1 minus x0. Step 8, that is u equals to a minus x0 by h. Step 9, assign sum y0 0 and p equals to 1.0, that is p is product. Now step 10, for j equals to 1 to n minus 1 and we have to find product. So formula of product is p equals to p into u minus j plus 1 by 1. Sum equals to sum plus p into y0 j and j. So sum का भी formula आ गया. Step 11, display a and sum, and step 12 stop. Now next question, we have to write Python code or C code for Newton difference interpolation formula. So Newton difference interpolation formula is a technique used to build an interpolating polynomial from a set of data points. It's more flexible than other interpolation methods and works even when the x values are not equally spaced. Section 2, overview of the problem. Let's say you are given a set of known points like x equals to 5, 6, 9, 11 and y equals to 12, 13, 14, 16, and you are asked what is the estimated value of y when x equals to 7. That's where Newton divided difference comes in. Section 3, divided difference table. This functions calculate the divided difference table. It uses a nested loop to fill the table using formula fxi xi plus 1 equals to fxi plus 1 minus fxi by xi plus 1 minus xi. Each column represents one level of difference. Now inside the loop, here the outer loop controls the level or order of the difference. The inner loop computes values row-wise using divided difference formula. We are storing results in the same 2D array y dash dash. Now these functions calculate the interpolated value at a specific x equals to value using the Newton polynomial. We start with the first y value. For each next term, we multiply value minus xj to get the product. Then we multiply it with the corresponding divided difference from the first row and add it to the result. In section 4, that is the main function, we define n equals to 4 data points. We initialize x values and y values. Only the first column of y is filled. The rest will be filled by the function. Now we calculate the divided difference table, then evaluate the polynomial at x equals to 7 and finally print the results. And that's how Newton divided difference interpolation works in C. This method is fast, efficient and very handy in numerical analysis. Now moving forward, the next question, that is Lagrange interpolation formula. So we have given formula. Now assume all yi equals to 1, but if all yi are 1, then the function is constant. Px equals to 1 for all x. Therefore, L0x plus L1x plus 2 ln x equals to 0. So basically we start with the Lagrange interpolation formula. Now assume all yi equals to 1. So the equation becomes that Px equals to summation from I equals to 0 to n for Lix. But if all values are 1, the function is constant. So the interpolated polynomial Px equals to 1 for all x. Hence L0x plus L1x to ln x equals to 1. Therefore prove the sum of Lagrange coefficient is 1. Now Simpson's rule from general quadrature formula. So given formula, this formula gives the approximate value of an integral using weight C0, C1 and step size h. The weights depend on how many points we take and what kind of interpolation we use. Apply for 3 points n equals to 2. To get Simpson's 1/3 rule, we choose 3 equally spaced points, so n equals to 2. Let x0 equals to a1, x1 equals to a plus h and x2 equals to b. Step size h equals to b minus a by 2. Now use quadratic interpolation, that is second degree polynomial, to find the weights. C0 equals to 1, C1 equals to 4, C2 equals to 1. Now substitute in the general formula. Now plug the weights into the general formula. This is called Simpson's 1/3 rule, which is integral of from a to b fx dx approximate h by 3 fx0 plus 4fx1 plus fx2. Now general formula gives a structure. Use 3 points plus quadratic interpolation and you get Simpson. Now Newton-Cotes formula is a general method to approximate definite integral by fitting a polynomial equally spaced points. When we take 3 points, that means n equals to 2, the interpolating polynomial is of degree 2, a parabola. Let the interval be a comma b and divide it into 2 equal parts. So step size is h equals to b minus a by 2. The points become x0, x1, x2. Now for n equals to 2, Newton-Cotes gives the weight. 1 for fx0, 4 for fx1, 1 for fx2. So the formula becomes this. This is exactly Simpson's 1/3 rule. So Simpson's 1/3 rule is actually a special case of Newton-Cotes formula for 3 equally spaced points. That's how we derive it using Newton-Cotes formula. Now some concepts. That general formula gives a structure. Use 3 points per plus quadratic interpolation and you get Simpson's rule. And Newton-Cotes formula is given points are equally spaced. The function is approximated using polynomials of degree n. The weights are derived from Lagrange interpolation. So thank you and keep learning and keep watching.